Hello and welcome to helpyourmath.com. In this video, we're going to look at examples of simplifying variables with exponents. And just some tips are my suggested steps for success. First, distribute exponents if there are parentheses. And remember, when we're talking about powers raised to powers, we would multiply. So if we have x to the m to the n, this would be x to the m times n. Then I like to move any terms with negative exponents. So if an exponent is negative in the denominator, then it is positive in the numerator. If an exponent is negative in the numerator, then it is positive in the denominator. After that, I combine factors with the same base in the numerator. I combine factors with the same base in the denominator. And then lastly, I simplify factors of the same base that's in both the numerator and denominator. So by the end, I should just have one of each type of factor. So if there's a base x, there's only one base x in the problem. If there's a base t, there's only one base t. And one other thing I didn't put on here, but if there are numbers we would simplify like the normal fractions that they are. So sometimes we get so hung up on the rules for exponents or the properties of exponents that we then try to apply them to numbers. No, we simplify those the way we always simplify numbers. So if we have 2 over 6, that would just simplify to 1 over 3, right? Because we would divide these both by 2. So make sure you're really careful about that, because I know it's really easy to get carried away with the properties of exponents. Let's look at our first example. We want to simplify and we want to make sure that the answer only has positive exponents. So let's see. First thing I would do is distribute that negative exponent. So I'm distributing the negative 2 to every single factor. So this would become negative 5 to the negative 2. This would be x to the negative 3 to the negative 2. Wait a minute, y to the 0, I'm going to go ahead and get rid of that. Y to the 0 is just 1, so that factor just goes away. It becomes 1, which we don't need, so I don't need to worry about that. Then we have z to the 7th to the negative 2. In the denominator, we have 2 to the negative 2, x to the 4th to the negative 2, y squared to the negative 2, and z to the negative 2. You'll notice I just separated everything. Normally I wouldn't do this much work, but it's kind of just nice to see what I've done. Another really common mistake that I see students do is they forget to raise those numerical factors to that exponent. The negative 5 and the 2 also get raised to the negative 2, so we want to make sure we're taking care of that. Okay, the next thing I'm going to do is I'm going to actually use that power to a power and multiply the powers. So this would give me negative 5 still to the negative 2. This here would be negative 3 times negative 2 is positive 6, so x to the 6th. 7 times negative 2 would be negative, sorry, I don't know why I put a y there, negative 14. In the denominator, I'm just going to leave it as 2 to the negative 2. This would become x to the 4 times negative 2 is negative 8. 2 times negative 2 is negative 4. And this would have an exponent of 1. This would just become z to the negative 2. Okay, next thing I would do, anything that has a negative exponent, I'm moving it. So that negative 5, that will become negative 5 to the positive 2 when it's in the denominator. Notice when I move it, it's still negative 5. The only thing that changes signs is the exponent. So still negative 5, but the exponent is now positive, being in the denominator. X to the 6th is going to stay where it is. Z to the 14th is going to move down. So I've taken care of this, this, and this. In the denominator, 2 to the negative 2. I'm going to put the 2 actually out in front. This would be 2 to the negative 2. X to the negative 8 downstairs wants to move upstairs. Well, it will be x to the 8th. Y to the negative 4th will be y to the positive 4 in the numerator. Z to the negative 2 will become z to the positive 2 in the numerator. Okay, now we're going to clean up the numbers, the numerical factors, and I'm going to look in the numerator to see if I have any common bases, which I do. I have 6 x's here and 8 factors of x here. How many factors of x do I have total in the numerator? Sorry, I moved the 2 up, but then I made it negative anyway. Silly me. Okay, that would be a total of 14 x's. So I have 2 squared, 4 times x to the 14th, and then y to the 4th, z squared, over, and then in the denominator, negative 5 quantity squared is 25, z to the 14. Now I'm going to keep the 4 and the 25. Those don't simplify. They don't have any common factors. X, there's only one base x, so it's just going to stay x to the 14th. There's only one base y, so it's going to stay y to the 4th. For the z's, I have 2 factors of z in the numerator, and I have 14 factors of z in the denominator. That means that I have more factors of z in the denominator. So when we simplify z squared over z to the 14th, we could think about z to the 14th as z squared times z to the 12th, and then the z squares would cancel, and we would still have 12 factors of z in the denominator. So we would say z to the 12th. Okay, we've totally simplified. We have one of each type of base, right? We have x, y, z, and then our numbers, and everything's positive. So this would be our simplified version of what we were given. In our next example, okay, the first thing I suggest doing is distributing, wait a minute, is this a trick? We're distributing a 0? Well, wait, what's anything raised to the power of 0? Anything raised to the power of 0 is 1. So this would just become 1. The end. All done with that problem. What about this one? Our last example, not quite as nice as that middle one, is it? Let's see what we have here. First thing I want to do is distribute anything that's outside parentheses. So I'm going to distribute this -3. This -3 just stays -3. And then it's going to be -2 to the -3, and f to the -2 to the -3, g to the 4th to the -3. So I've distributed the -3 to the 3 factors that are, or 3 bases in the numerator that were in the parentheses. In the denominator, I'm distributing this -1, so it's going to be 6 to the -1, f to the 5th to the -1, g to the -7th to the -1, h to the 4th to the -1. Okay, so all the bases in that first set of parentheses are good. How about the second set of parentheses? We have f to the -3rd squared, g squared, and h squared squared. So now everything's kind of separate. I want to just figure out what everything is using the power to a power. And we're going to get -3. Then we have -2 to the -3. I'll deal with that in just a second. Here we have power to a power. That's going to be f to the 6th. Next we have g to the 12th. In the denominator, I'm going to deal with this in just a minute. I have f to the -5th, g to the +7, right? Because -7 times -1 is +7. H to the 4 times -1 is -4. F to the -6th. This will be g squared, and h to the 4th. Okay, the next thing that I do, anything that has a negative exponent, I'm going to move its location. So let's see, -3 has a positive exponent because it would have an exponent of 1, so it's going to stay where it is. -2 to the -3 is going to move down, where remember the base stays the same, so it's still -2. It's the exponent that becomes to the 3rd power. F to the 6th is happy where it is. G to the 12th is happy where it is. 6 to the -1 in the denominator. We have a negative exponent. Let's move it up. I'm going to put it right behind that. That would be 6 to the 1, which would just be 6. F to the -5th wants to move up. G to the 7th wants to stay where it is. H to the -4th wants to move up, where it'll be +4. F to the -6 wants to move up, where it'll be +6. So we've got that one. G squared is happy in the denominator, and h to the 4th is happy in the denominator. Okay, next I want to simplify across. So along the numerator, is there anything I can simplify? Yes, there is. First of all, -3 times 6 is -18. Then I have 6 factors of f, 5 factors of f, and 6 factors of f. So how many factors of f do I have in all? It would be 6 plus 5 plus 6, which would be 17 factors of f. Then I have 12 factors of g and 4 factors of h. In the denominator, I'm going to go ahead, -2 cubed would be -2 times -2 times -2, that's -8. Then I have g to the 7th times g squared. That would be a total of g to the 9th, and then h to the 4th. The next thing I want to do is look to see if I have any common bases between the numerator and denominator. When I look at these numbers, they're not necessarily common bases, but they are numbers, and they do have a common factor. First of all, they're both negative, so that's going to turn this whole thing positive. And then 18 and 8 are both divisible by 2. So I'm going to rewrite 18 as 9 when I divide it by 2, or -18 by -2, and -8 by -2 would give me +4. Then I have just this one single base f, so it's going to be f to the 17. I have 12 factors of g in the numerator, and I have 9 in the denominator. So we can think about these 12 as g to the 9th times g to the 3rd, and that would mean I have 3 factors of g remaining in the numerator, right? There were more in the numerator, so there should be only g factors in the numerator. Here, we have the same thing. So because they're equal, anytime we have a common factor in the numerator and denominator, they become 1. So this would be my very awkward answer since the 4 is kind of off to the left, but that's okay. We end up in the end with 9f to the 17th g cubed all over 4. This one can be really tough. It's very easy to make mistakes. That's why I went step by step to make sure that there were no mistakes made. And so I encourage you to take your time with these. Don't try to rush through them because it's just so easy to make a mistake with these. These have been examples of simplifying expressions with exponents. Thank you for stopping by.